Hello everyone, this is Richard Burton back again to you from Hand Tools, and today we're going to look at chapter 12, which is going to be wrenches and screwdrivers, which I know most of you probably, if you had to guess of any type of hand tool, as far as like naming a hand tool, a wrench or a screwdriver would probably be the most obvious one. So probably on this chapter there's going to be a lot of information in here that you're already going to know. So hopefully maybe we'll talk about something in this chapter that you didn't know, so you can gain a little bit of extra expertise about wrenches and screwdrivers. So this is going to be, like I said before, chapter 12, and it begins on page 171. And the first thing it talks about is wrenches can be made out of all different types of metals. Of course, we know that all tools are pretty much made from metal. And it mentions that if you have a wrench that is a very good quality wrench, most of the time it's going to be made out of what they call chrome vanadium steel. And this right here says it on there, chrome vanadium. And what that means is usually the wrench is going to be lighter weight, but also very strong. Because normally when we're using wrenches or any kind of hand tools, we don't want to have to use something that's extremely heavy. Because even though we don't really think about it when you're working with tools all day long, a really heavy tool can begin to tire you out if you have to carry it around, or either you're holding it up, using it quite a bit. You know, you want the wrench to be as light and as strong as possible. And so that chrome vanadium steel means that this is probably the best steel that you can get for tools to be made from, especially wrenches. The next thing it talks about is that most bolt heads and nuts are made in what they call a hexagonal shape, which means it has 6 sides on it. One thing to think about when you're thinking about 6 sides is that these sides are equally flat, opposing each other. So as a wrench goes on it, of course, the flats meet up with the wrench so you can turn it. So every time it comes around, it's got 2 opposing flats that you can turn. Nothing really complicated about that. Just wants to make you aware that's the shape of the bolt head or a nut that goes on the bolt. The next thing it wants to talk about, or the book talks about, is an open-ended wrench. So we know of wrenches to be a lot of different styles. This particular wrench is considered an open-end wrench. And the reason being is that the ends right here on both sides are open. This wrench happens to be an open-ended wrench with 2 different sizes on one end. So you've got 11/16 over here and a 13/16 over there. So this wrench can serve the purpose of 2 different sizes at the same time because both sides are open-ended. Another wrench it mentions is what we call a box end wrench, which this wrench right here would be considered a box end because it's boxed all the way around the bolt head. And also this wrench is another thing too, it's also considered a offsetted wrench because most of your wrenches only have one offset, like this one here. This one has a double offset. So I say double offset, this is an offset wrench, so it has an extra offset. They also make a deep offset, which would even have more offset than this one, but this particular one here is just a regular offset. But it gives you more room to allow for more clearance as you turn a bolt. Other things that would normally be in the way of the bolt would not interfere as you tighten or loosen the bolt. One thing to keep in mind with box end wrenches is it mentions that box end wrenches can sometimes come in either 6-point, which would be a point that looks like that right there, or a 12-point, which looks like this right here, which means you have more positions that you could fit this wrench onto a bolt head. The only thing about extra points usually indicates though that there could be more likelihood of you wringing the bolt head off if it's extremely tight. So when you have multiple points other than the regular 6-point, you want to be aware not to over tighten with this style of fit. Otherwise, you could take a chance on earring off the head of the bolt. You know, because those flats, once you turn these flats too much and you get those down, what do you have left but the shape of a circle? So you don't want to ring off a bolt by putting too much pressure on it. And it also says 6-point and 8-point wrenches are used for heavy duty turning. 12-point wrenches are used for medium duty turning. And they also make a 16-point wrench, which is for what they consider very light duty turning. So the more points you have, the more likelihood of having contact on the bolt head. The next thing it talks about is what most of us are familiar with, most familiar with, trying to say that, is the combination wrench, which means it has a box end on this, a box end on this side and an open end on this side. So as we look at this wrench here, you need to remember that this is now the same size over here as it is over here. This will be more likely to be your light duty side, and this will be more of your heavier duty side when it comes to turning, because this could actually, if you put enough force on it, spread open, where this right here will be more likely to maintain its hold on the bolt, even though this is, like we just talked about, a 12-point. So in any case, you don't want to do major heavy duty turning with this, but if you're going to choose between which side to do it on, it's better to do it on the box end side. And then it goes into talking about socket wrenches. So most of us know what a socket wrench is. If not, the socket is, this is removable. There's multiple sizes of this, and this fits onto a wrench, just like so. This happens to have a lock on it, so you have to press the button to release it. That can be very handy when you're working on something where possibly you're down inside of something where you can't really see. You don't want the socket just pulling off and staying stuck to the head of the bolt. With this, it will not do that, because you have to actually hit the release button to make it release. And one thing to keep in mind with sockets is sockets are sized according to their drive. So this right here is considered a 3/8 drive, this square right here. So this square is 3/8, and so this socket wrench is 3/8. So it's a 3/8 socket drive, which is a square drive, and it fits on there like so. They usually make them in quarter, which is smaller than this, and then they make a drive which is 1/2 inch, which is larger than the 3/8. So as you get up in larger sizes, you have to have a socket like this that matches that drive size in order for it to interchange with it. Another thing to keep in mind is sockets come in various depths. You've got a deep well and you've got a regular or shallow style socket, which means this more likely will not fit over a nut that has a thread that's run out the other side of it, and you try to stick that on and the thread sticking through, it's going to hit that before it actually gets down there to the nut, where this right here will allow that to pass over the thread sticking out and get to the nut. A lot of times you see, if the bolt's extra long or they're using the bolt to pull something up tight, they may have to start the threads out and then draw whatever it is onto a possibly like onto a counter set fit or whatever, and so they're using the threads of the bolt to actually assist in pulling up whatever you're bolting down. So a lot of times you wind up with a lot of extra threads coming out of the other side of the nut, and so a deep well is going to assist with doing that better than a shallow well. They do make a lot of different types of socket handles. This particular one is called a ratchet, because when you put it on, one way it freewheels, the other way it locks. That way, as you ratchet on something, you can speed up being able to go back and lock back and forth, back and forth. This also has a small lever that you flip, and that changes the direction of which way you're turning it. Flip the lever and then it goes and ratchets the other way. So as we know, you have to loosen a bolt by turning it one direction, tighten it by turning it the other direction. So depending on if you're tightening the bolt or you're loosening the bolt, you need this lever placed in whichever way. So for most right hand threads, you would push the lever to the right, and for left hand, for right hand threads, you're going to be loosening. You're going to have the lever to the right. For tightening right hand threads, you're going to push it to the left. Sorry about that. I didn't want to confuse you on that. Another thing that they use is a breaker bar, which this doesn't have any ratcheting to it. It's just got a way to go from one side to the other. You can place a socket on it, and this gives you a tremendous amount of leverage. So when you're on something, you can put maximum force on it to loosen it up. Another thing that, get this up right quick. Another thing that assists you with speeding up, tightening something down is a speed handle, which looks kind of like something. If this is sitting stationary, you can spin the handle, and that's going to basically spin around, which speeds up tightening up bolts. That's called a speed handle. It says the fastest manual way to do it. Most of the time now with cordless power tools, we probably opt to use those instead of the other. So another type of wrench is one that we're very familiar with. It's called a socket screw wrench, designed for fitting socket head cap screws. And most of us know these as Allen wrenches. That's kind of like the brand name of it. And this is also hexagon in shape. And this just fits the opposite of fitting on the outside. This fits on the inside of bolts. They also make a wrench that's similar to this called a multi-spline, which splines are used in a lot of ways to tighten and loosen like automotive type fasteners. You see spline screws a lot in automotive, and you get more contact points than you would on a regular Allen screw. So you'll be less likely to strip it out when turning on it, and the head can be, smaller to be able to handle more force. Okay, next thing it talks about is adjustable wrenches. So we pretty much familiar with these. Adjustable wrench takes place of having a whole entire set of wrenches, right? Now we don't have to worry about the bolt head being metric or standard. We just take it and adjust it to whatever size we need it to be, and it locks down. One thing that a lot of people do not realize about an adjustable wrench is there's actually one direction that this wrench is supposed to be turned. It actually has an arrow on the handle that shows you which direction this needs to be turned. So if you're tightening a bolt, you turn it this way. If you're loosening a bolt, you take it off, you turn it around that way, and you loosen it that way. So either way you're turning it, you need to be always facing with the adjustable jaw the direction you're turning. So that way the solid part of the wrench right here is taking all the force, and the adjustable jaw actually is just designed to cam in and lock to it as you pull pressure on it. If you've ever had an adjustable wrench slip off of a bolt when you're using it, more than likely you had it turned the wrong direction. You had it like this on the wrench and you were trying to turn it down. So you had all the pressure on the adjustable jaw and it pushed itself loose and it slid off. If you would have had it in the right direction of the adjustable turning, it would not have probably slipped off of there, because usually it gets tighter onto the bolt head when you're tightening, when you're putting pressure on it, than when you're actually adjusting it down. So that's one thing to keep in mind with adjustable wrenches, is make sure you turn them in the right direction when you use them. They're actually very handy tools. Having one of these can save you from having to carry every size wrench that's made just to be able to tighten and loosen bolts. The next thing it talks about is a torque wrench. So with all the wrenches I've talked about before, we pretty much tighten everything down to whatever amount of torque we can put on it. So the bigger the wrench, the more torque can be applied to to a bolt. So as you have a large size bolt, you have a larger wrench, so you can put more torque on it. But in some cases, we need to know exactly how much torque is being applied to a bolt. One example would be if you're changing out a flat tire and you tighten down the lug nuts on your car. If you over tighten those lug nuts, the next time you try to take that wheel off, you may not be able to get it off with a regular lug wrench. You may have to have some kind of impact gun to get those lug nuts back off because you over tighten them. So it's always important to kind of tighten something down with enough torque that you know is tight, but not so much that you over tighten it. So a torque wrench can do just that. You can set it to exactly the torque you want it to be. And based on what the torque setting is, when you put pressure on it, like this right here, you hear a click. And when you hear that click, that's the indicator that you tighten the bolt down to the recommended torque setting that you have on the handle here. So you can adjust this torque setting just by turning the handle. The more you turn the handle in, the higher the torque that's going to be applied to the bolt goes. And like I said before, the drive size of this is a 1/2 inch. So with a 1/2 inch wrench, you can apply more torque than if you had a 3/8 torque wrench, because this is a larger bodied wrench, it's bigger. And two things that a torque wrench does is it tightens the bolt, and then it also measures the tightening force of the bolt. So you can actually use this wrench just to regularly ratchet a bolt on. And then once you get it as tight as you want it, you can set the torque and it'll click and let you know you tighten the bolt down to the right pressure, the right torque. So that's what a torque wrench does. Next thing it mentions in the book on page 178 is using wrenches safely. So how do you use a wrench safely? So there's really not too many things that I can think of where you would have an issue with a wrench being dangerous, except for maybe the technique that you use. The book mentions that when you're using a wrench, you're safer to be pulling on the wrench versus pushing on the wrench. And the reason being for that is when you're pulling on the wrench, you're kind of leaning slightly back. I mean, you don't want to have your feet all the way up underneath what you're pulling on and using the wrench as basically like a lever to hold your body weight up. But you want to get a good stance, and then you want to pull on the wrench, whether you're tightening or whether you're breaking the bolt loose, whichever way you need to be set where you're pulling on the wrench is safer. It also says if you're going to push on the wrench, so you can't get over here to break the bolt loose from this side, so you're going to have to break the bolt loose by pushing on it. It says do it with an open hand. So if you're pushing against the wrench with an open hand, you're less likely for something to break loose and your hand traveling forward and possibly hitting something on the other side wherever you're working. Another thing it says you can do is if you put the wrench on a bolt, you can also take a hammer and use a hammer to lightly tap on the wrench and cause enough force to break the bolt loose. They also make a specialty wrench called a striking face wrench. It's basically like a wrench like so with a block on the end of it, and you can use the hammer to strike on that, and it gives you, you could use possibly a small sledgehammer if you needed to break a bolt loose if the bolt was extremely tight. One thing to keep in mind, the larger the bolts, the tighter the bolts are going to be. So if you're just dealing with little small headed bolts, then you probably would never need a striking face box wrench. But if you're working on really large bolts, that's probably something that you're going to have in your toolbox to use all the time to break really large bolts loose. Okay, so now we're going to look at screwdrivers. So it says with all tools, you should always select the right screwdriver. And most of us know, when you think of screwdriver, most of us probably think of screwdrivers as a flat-headed screwdriver. So flathead screwdrivers are pretty much considered like standard bladed screwdrivers, the cross slot screwdriver. It says most screwdrivers handles are usually made out of, certain kinds of materials. This one happens to be made out of some kind of hard plastic. And this one happens to be made out of some kind of hardwood, but it is wood. And then this handle here is made out of some kind of insulated rubber. So you got 3 different kind of handles: plastic, wood, and rubber. So those are 3 different materials right there. It also mentions that when you have a wooden handle screwdriver, that normally the handle has a ferrule. And what happens, they place the shank up inside the handle, and then they press a ferrule over the end of the shank that locks it to the wooden handle. So that ferrule right there is important to basically keep the blade locked inside the handle. So as you use this blade, it's not going to basically strip out the wood inside there. So it kind of gives the wood a reinforcement. Otherwise, the wood probably wouldn't hold up very long. Another thing it talks about is different types of tips on these blades right here. You've got a regular flange tip, which means that it flares out. And then you've got a straight tip, which is for electrical. Notice this is an electrical screwdriver because it's an insulated screwdriver. The shank's insulated and the handle's insulated. And the blade is actually straight right here. There's no flange or flare to this tip. And most of you probably would know this if you've worked around any electrical components. But most electrical components like terminals usually recess into plastic coverings and plates. And so you can't have a flared edge screwdriver blade to fit around or fit into those recessed plastic covers. So you need a straight bladed, they call a parallel tip screwdriver, which means it is parallel all the way down on the sides. Another thing it talks about with screwdrivers is, of course, you've got your cross slotted screws, which is like your Phillips screwdrivers. And then you've also got a different type of cross slot screwdriver called a reed and print screwdriver. And the main differences are the angles of the tip. If you've ever noticed before, you've got certain screws that have a different angle than a regular Phillips. That's because the screw is actually a different style screw. It requires a different angle of a Phillips screw to actually drive it. So that's why you got a Phillips and you've got what they call a reed and prints. The reed and prints is not probably a very popular fit that most of us are familiar with. Sometimes they just they don't catch a lot of popularity, so you don't hear much about those. And then lastly, it talks about how to actually drive a screw, which if you're placing a screw into a hole to drive it, it says always put the screw up against the surface and then put a light tap of pressure on it to make sure the screw is like started into the hole. And then as you begin to turn it, you start to turn the screw in there. If the screw begins to get hard to drive, it says you can place a light coating of either some kind of lubricant like soap, wax, graphite, cutting oil of any kind that would help the screw go in easier. So if you've got a screw that you're driving in a hole and it starts to get extremely tight and you still got to finish threading it in and you can't get it to go anymore, you need to take that screw out. You need to check to see if the hole's deep enough, or there's enough threads in there, or if it's a self tapping screw, you need to put some kind of oil or something on it to help get it moving, because sometimes they just bind up from the material that you're trying to turn them into, and you need some extra lubrication there to help out with that. Last thing it talks about is restoring a screwdriver blade. And after you use a screwdriver for so long, sometimes the parts of the pieces of the ends of the screwdriver there, the edges, start to get kind of worn down. And if they get worn down, you can take them on a grinding rock or a belt sander, and you can basically grind that back down to a good, clean, flat edge again, and then the screwdriver is basically like brand new. So you can take that. It does say in here, do not try to use a hand file to do that, because a lot of times these tips are hardened. So if you try to file them, you're not really going to have any luck trying to file a hardened tip screwdriver blade. Okay, that's all I've got for today. If you notice, I'm doing this today outside of my garage. It's very hot in here, and it's turned into summertime. So I probably will not do any more videos for the next 2 chapters, because they're going to be on metric measurements and safety. And I'm going to probably just send you a chapter review summary for those 2 chapters, and we will be pretty much finishing up. And the next test will be on the wrenches and screwdrivers, metric measurements, and safety. So be ready for those 3 chapters to get completed, and then the test, and then we should be getting in the lab in the next couple of weeks. So see you then.